Hello, everyone. So in this video, we're going to start on the topics that we're going to be covering in this course. Before I start on section 1.1, which talks about functions, I'm going to talk a little bit about sets. I always like to talk about sets before I teach college algebra because there's a lot of set theory behind, and we can do it with just very basic set theory, but going over this first is going to make a lot of the things that we see later a little bit more clear. Okay, so again, this is not something that's in the book. At least not the way I'm presenting it. So for this, the only resource is going to be this lecture and the notes. And then once I get to chapter 1, section 1, I'll let you know that we're in that section already. And then something else that I want to say is the way the course is divided in terms of lectures, we're going to start covering only college algebra materials, and then eventually we're going to get to cover trigonometry materials. So if you go to the syllabus and you look at the list of topics, you'll see that the first couple of topics are just about algebra, and then eventually it turns to topics about trigonometry. Okay? So I'm kind of breaking the course into two different parts, right? The algebra part and the trigonometry part, with the algebra part done first. Okay? So having said that, let's start. Let's start with the definition. So what is a set? The definition is pretty simple. A set is a collection of objects with a common defining identity. Or property. Identity or property. Let's use property. Okay. So, for example, let me give you some examples of sets. Okay, so we could say the set of all cats. This is a collection of animals with the property that they're cats, right? So it's a set by definition. Let's do another one, something more mathematics related. So the set of all, let's say, even integers. So again, this is a set because we have a collection of objects with defining properties. In this case, we have the set of all numbers with the property that they're even. So a set of all numbers that are even. So again, you have a collection of objects with a defining property, or let me write properties. It could be more than one. Right, so here, for example, you can say, well, you have a set of objects. You have a couple of properties. Right? First of all, they're numbers, they're integers, and they're even. So you can say, okay, we have three defining properties for this collection of objects. And then let's do one more. Let's do the set of all, let's say, real numbers less than 5. So again, all of these are collections of objects with defining properties. Now, I'm going to give you a list of commonly used sets that we're going to be using in this class. So let me make some space here. Some of them we can't define yet, but we will, and some we'll define now. So commonly used sets. Okay. So first of all, we have the set of integers, right, which I mentioned in this example. So what's the set of integers? Well, a set of integers, which is usually denoted by, and this is going to be a little bit weird, but think of drawing a Z, the capital Z, with an extra line going from the top to the bottom, right, in the same direction. So a set of integers denoted by Z, and this is the set, and you're going to write sets. If you can list the items of the set or the elements, you're going to do it like this. You're going to open brackets, and I'm going to list all of the elements. Well, there's infinitely many, so I can't do that. So I'm just going to list a couple. So -3, -2, -1, 0, 1, 2. So I don't need this -3. But basically, this is the idea. What's the set of integers? It's just all of the counting numbers and their negatives, including 0. Okay, so that's the first set that we're going to be using a lot. Secondly is the set of natural numbers. which again has a way to be denoted, which we denote by mn with an extra vertical line. And we can write this down again. So 0, 1, 2, etc. Now, another way to denote this set is writing the integer symbol and with a subscript of greater than or equal to 0. So I'll probably be using the integer subscript greater than or equal to 0 symbol just so that we don't have too many symbols to work with here. The less, the easier. And then a couple more, just 2 more. The set of rational numbers, which I can't define yet. I need to do some things. And this one is denoted by the letter Q, again with a sort of line through it. So Q, and then you do a line like this. And then finally, the one we're going to be using the most is the set of real numbers. And this is denoted by an R, capital R, with a vertical line. So these are the commonly used sets that we're going to use. Then again, if you can enumerate all of the elements of the set, you can kind of do something like this, where you write the elements of the set inside curly brackets. Now here, of course, I'm not writing all of them, but you can understand from the 3 points on each side that I'm saying, okay, just continue this pattern. Okay, so to the right of 2, we have 3, 4, 5, etc. To the left of -2, we have -3, -4, -5, etc. Same for the set of natural numbers. We have 0, 1, 2, ... That means that you just follow the pattern. Okay, so 0, 1, 2, then 3, then 4, etc. Now, for the set of rational numbers and set of real numbers, again, there's a little bit more work that we have to do because there is a defining property for the set of rational numbers, but we need to introduce new notation for writing sets that I'm going to introduce in a moment. Okay. But that's basically the start. Right? Sets are a collection of objects with a common defining property. For example, the set of all cats, the set of all even integers, the set of all real numbers less than 5. These are all collection of objects with defining properties that they have in common. And these are the commonly used sets that we're going to use in this class.